Lesson 9.1, Graphing Quadratic Functions. In this video, you will learn to analyze the characteristics of graphs of quadratic functions and graph quadratic functions. Your vocabulary for this chapter is here. If you need more time to copy them down, you can pause. Okay, so quadratic functions, the parent function is y equals, or f of x equals x squared, and standard form is ax squared plus bx plus c, which is a parabola. We call the shape of this thing, which makes this like u, a parabola. That's the shape. It's called a parabola. And the axis of symmetry, so this red line here, like where it's symmetric, so if you pick any point on this side, it's going to be symmetric on this side, which means it's going to be the same distance away from that red line on either side. Any point I pick, there will be the graph the same distance away on the other side. Okay, so that's the axis of symmetry, and it's negative b over 2a. So you're getting b and a from your standard form of the quadratic function. And the y-intercept, so where it touches the y-axis, is always the point C. Okay, so we're going to use that information to graph at some point. But before we do that, we're going to start by making a table of values to graph. Okay, so that means we want to have x and y, and then we're going to use that to graph this. It's best to start with the vertex, and we want to have points on either side of the vertex, or the axis of symmetry. So remember, the axis of symmetry was negative b over 2a. So looking at this, if this is of the form ax squared plus bx plus c, in the place of a is 1, so we can say a is 1, b is negative 1, and c is negative 2. So if I want to know what the axis of symmetry is, AOS, that's going to be negative 1 over 2 times 1. So we get 1 over 2, or 1/2. Okay, so I want to have 1/2 in my graph, and I want to have some values less than it and some values greater than it. So I'm going to do 0, negative 1, 1, and 2. Okay, and then I want to figure out what the value is at each of these points. So I'm going to plug each of these values in for x into my function to find y. So if I do negative 1 squared minus negative 1 minus 2, then we're going to get 1 plus 1 minus 2, and that's 0. So I get 0 here. Okay, so I'm going to pause the video and finish this, and you guys go through and complete. So once you have your list of all the values, which you get by plugging them all into this equation, you can go through and graph them. So I'm going to graph the point negative 1, 0, 0, negative 2, 1/2, negative 9 over 4. So that's about 2 and like a fourth. About there. And then I have the point 1, negative 2, so that's there, and 2, 0, which is there. And so then I can get the idea that my shape is going to be more or less like this. And you get your problem. It's a little hard to draw on this tablet, but you guys can draw yours a little bit smoother. Okay? And the last step I want to do is state domain and the range. So my domain, remember, is the x values that are found in this. So my domain, this is going to keep going this way, and that's going to keep going that way. So my domain is going to be all real numbers. My range is the y. It starts down here at negative 9 over 4. That's the smallest value I have, and then everything is greater than that. So my y values are going to be greater than negative 9 over 4. Greater than or equal to, actually. Okay? And that's number 1. Number 2, we want to be able to identify these things from the graph. So the first thing we want to be able to find is the vertex. So the vertex, we call the vertex the point or the bottom or the base or the tip of a parabola. So that's that point right there. So my vertex, looking at the graph, is the point 2, negative 2. Okay, and then I want to find my axis of symmetry. The axis of symmetry always goes through the vertex. So that's like this line here. So the equation of this line is x equals 2 because anywhere along this line, x is 2. So my axis of symmetry is x equals 2. And the last thing I want to do is so the y-intercept is where it touches the y-axis, which is right there. So my y-intercept is going to be the point 0, 2, or if we just want to say 2, because we're talking about y-intercept, so it's obviously 0. And okay, we want to do the same thing for this one. So that's going to be the point, right, where it changes direction. So my vertex is going to be the point 2, 4. My axis of symmetry, again, goes through the vertex. That's this line here. And my axis of symmetry is going to be the point x equals, or the equation, the line x equals 2. Y-intercept is going to be where it touches the y-axis. So my y-intercept is y 0, negative 4, or just negative 4. Okay. Example 3. Find the vertex equation of the axis of symmetry and the y-intercept of this. Okay. So when you have the equation instead of the graph, it's a little bit more difficult, but it's still pretty easy. So the first thing to find is the axis of symmetry. And remember, from that equation, we said that it's negative b over 2a. So in order to do this, I want to figure out what I get when I have b and a. Okay, so I have negative 8 is b, so negative 8 makes this 8. And my a is negative 2, so 2 times negative 2. So 8 over negative 4 is negative 2. So if you look at this graph, one of the ones we just did, okay, the axis of symmetry, the x value of the vertex, this was the point 2, 4. The x value of the vertex is always the x coordinate of the axis of symmetry. So if I want to use that method, this is my axis of symmetry. So I already found out my axis of symmetry is x equals negative 2. But I can use that as the x coordinate of the vertex. So it's going to be negative 2 something. How do I figure out y when I know x? Well, I put x into my equation. So I'm going to put in negative 2 there. So I'm going to have negative 2 times negative 2 squared minus 8 times negative 2 minus 2. So I get 4 times negative 2 is negative 8 plus 16 minus 2. So I get 6. So now I have my vertex. And then, right, the last thing in our equation, remember, this is ax plus by x. Sorry, what am I saying? Ax squared plus bx plus c. So c is always the y-intercept. So my y-intercept is 0, negative 2, or negative 2. Okay? So doing the same process again, we need to do negative b over 2a. So my b is 6 and my a is 3. So I'm going to have negative 6 over 2 times 3. So I get negative 1. So this is my axis of symmetry. And I still need to find my vertex. So I'm going to use as my x coordinate to find the y. I plug it in. So I'm going to do 3 times negative 1 squared plus 6 times negative 1 minus 2. So I get 3 minus 6 minus 2. So I get negative 5. So 1, negative 5 is my vertex. And then last thing, the y-intercept, which is just c. So y-intercept is negative 2. Okay. If we want to find the minimum and maximum, they always occur at the vertex. So The graph is going to go downward, so it's going to like open like this and point down and have a maximum when a is less than 0. So if the number in front of x squared is negative, that's when you're going to have a maximum. If it is positive, so that if a is positive, then you're going to have a minimum. It's going to open up. Okay? And the vertex, like I said, is always the minimum or maximum. So if you're trying to find the min or max, you need to find the vertex. So if I want to find the vertex or the minimum or maximum, I need to determine if it's a minimum or maximum. So because this here is negative, that means it's going to open down like that, which means that this is going to be a maximum value. Okay? Part 2, we need to state what the minimum or maximum is. So in order to do that, I need to do the negative b over 2a. And when I do that, I get negative 2, so 2 over 2 times negative 1, so I get negative 1. And I need to figure out what that is when I put in negative 1 into my equation. So I'm going to do negative 1 squared minus 2 times negative 1 minus 2. So this becomes negative 1 plus 2 minus 2. So I get negative 1. So I have a maximum value at negative 1. The y value is the max or min. Okay? Max. Okay? If I have this one, I want to state the domain and range of this one. So if the minimum or maximum, if negative 1 is a maximum value for that, that means all of the other y values are going to be less than that. So I'm going to say my domain is always going to be all real numbers for parabolas. So my domain is all real numbers, but my range is going to be y values that are less than or equal to negative 1. Okay, so the steps for graphing a quadratic function is to find the equation of the axis of symmetry, find the vertex and determine whether it's max or min, find the y-intercept, use symmetry to find additional points on the graph if necessary, and connect the points using a smooth curve. So we're going to do this really quick, okay? So first thing I need to do is find the the vertex, axis of symmetry, and the, what am I thinking? Vertex, axis of symmetry, and y-intercept. Okay, so I'm going to find these, and you guys can pause the video and solve for those right now using the methods we just used. Once you find those 3 things, we can start to graph those things. So we're going to start with the vertex, which is 5 over 2, or about 2.5, and 17 over 4, which is 4 1/4. So we go 2.5 to 4 1/4, and we get this point about there. So that's our vertex. Okay. Then we can graph our axis right through the vertex, and it's going to be a vertical line like this at 2.5 about. Okay. And then I'm going to graph my y-intercept. So it's going to be this point here. Now, because this is a line of symmetry, if I have this point here, I'm going to have a point that's symmetric to it, 1, 2.5 spaces on the other side. So 1, 2.5 spaces, it's going to be here. So now I have 3 points. I can see the general shape of this graph and draw it. So I'm going to draw this parabola coming like this. And you get the basic shape like that. Okay? For the sake of time in this video, I'm going to skip this one, but I want you to see that you can also do this by using a graphing calculator to do this. I wouldn't expect you to maybe necessarily draw this one, but if you use a graphing calculator, then you can do what we did in the other examples by looking at the graph to find the intercept and the maximum and minimum. So in this case, the maximum of the height of the ball that's shot, or the arrow that's shot, that's going to be what you get when you put in the vertex, the x value of the vertex. You're going to do negative b over 2a, and you'll be able to solve this. Okay, if you want to try this one on your own, I would encourage you to do it. I just don't have time to do it in this video because I can only record for 15 minutes. So I'm going to stop this video here. If you have any questions, we'll go over it tomorrow in class.